Today we are going to be looking at factoring quadratic expressions, and mine is going to start on page 23. We are starting Unit 3, which is all about factoring quadratics. On page 23, I've titled my page with Unit 3A, Factoring Quadratic Expressions. We're going to take a look at a couple of different types of factoring. The first is going to be factoring the greatest common factor. The greatest common factor is the largest number or variable that each term has in common. You will see mine already worked out, and I will explain each of the problems as I go through them. So in example 1, I start off with 12k minus 18. I'm looking for my greatest common factor, which happens to be 6. So I'm going to come over here to the blue. I'm going to divide both of my terms by the greatest common factor of 6, and that results in the pink answer, 2k minus 3. I'm then going to take my greatest common factor and my simplified form and put them together, and this is my factored expression. Example 2 gets a little bit more complicated because we are taking a look at multiple parts. So here you can see that we have 40 x to the 8th y plus 64 x to the 4th y. I'm looking at both the numerical and variable expressions to see what they have in common. Both 40 and 64 are divisible by 8. And I can take x to the 4th y into both of these variable expressions. So as you can see, I rewrote my original problem in blue, and then I'm dividing it by each term by my greatest common factor. That is resulting in me using my exponential rules, where I use division. I subtract my exponents, and I divide the coefficients, resulting in 5x to the 4th plus 8. So I take this plus my greatest common factor and I rewrite it in factored form. Remember, you can pause at any time. My third example is similar to the one above. This time I have 3 terms, 3 numbers, but 1 variable that I'm looking at. My greatest common factor of 14, 35, and 7 is 7. My greatest common factor of m to the 6th power, m cubed, and m squared is m squared. So I divide each term by that, resulting in 2m to the 4th minus 5n minus 1. So I take this plus my greatest common factor multiplied together to create my factored form. My last example, using the GCF, actually shows what happens when something completely simplifies out. So here, my greatest common factor is AB. So I'm dividing each piece by AB. In the first term, 3AB squared, the A's simplify out to leave me with a 3B. In the second term, 5A squared B, the B's simplify out to leave me with a 5A. And in the last term, the A and the B simplify out to leave me with just the 8. So I take my greatest common factor of AB and I multiply it by my factored form. These are all examples of greatest common factor. On the next page, you are going to see what happens when we take a trinomial, ax squared plus minus bx plus or minus c, and we factor this. These examples are where a is equal to 1. But remember that when factoring, we always want to look for a greatest common factor first. I'm going to show you 2 methods to factor a trinomial. The first is called factor by grouping. I am going to take and I'm going to replace the middle term, 14x, with 2 factors of 45. This is my c value, that add up to the middle term, which is my b value. And you can see that I've done some factor trees over here to pick the right 2 numbers that add up to 14, and that was 9x and 5x. So then My second step is to group together the first two terms and the second two terms and find the GCF of each group. So x squared plus 9x, I can divide everything by x, so I factored out an x here. And 5x plus 45, I can divide everything by 5, so I factored out a 5 here. The two groups that are left should match, which means that my factored forms when regrouped together are x plus 5 times x plus 9. And that is my factored form using grouping. Pause at any time. The second method is what some call the box or area model. It's very similar to the grouping method, but this time you're putting your trinomial in a box, replacing the middle two terms with the two numbers that multiply to give you the end value, which is c, and add up to give you the middle term, which is b. So again, instead of doing my factor tree, I just wrote out what numbers multiply to give me -8 and add up to give me a +2. And you can see that one of them fails, and so I choose the two that don't fail, the -2x and the +4x. The difference here is that we are going to factor each column and each row. So you can see here that x squared and -2x have an x in common. 4x and -8 have a +4 in common. X squared and +4x have an x in common, and a -2x and a -8 have a -2 in common. And so I take the two factors that are on the outside and I group them together to be my factored form. The last method of factoring is what happens when a is not equal to 1. And there's lots of different methods. This is a fun one called slip and slide. We are going to slide the c value, the a value, to the end of the trinomial and multiply it times the c. So if I take the 2 and I multiply it times the 3, I get x squared plus 5x plus 6. It's like I'm factoring a brand new trinomial. What are my two factors of 6 that add up to 5? And that is going to be a 3 and a 2. And I have x plus 3, x plus 2. Now I'm going to divide both of my factors by the value that I slipped over in step 1. So the 2 that I slipped over, I'm going to take x plus 3 divided by 2 and x plus 2 divided by 2. I'm going to reduce any fractions and then slide any denominators up next to the variable. So I can't simplify this. So the denominator of 2 comes next to the x and then plus 3. I can actually simplify this to be x plus 1, so I don't need to go any further. We're going to do a few more examples. We are going to slip the 5 next to the 6 and multiply, so we have m squared minus 17m plus 30. Now I'm going to think of what two factors of 30 add up to -17. Now think about the fact that we have a positive here and a negative here. Remember that when two negative numbers are multiplied, they are positive. So we're actually looking for two negative numbers. And we want -15 and -2. And we are going to divide -15 by 5 and 2 by 5. Now I can simplify 15 divided by 5, that's m minus 3. But I can't simplify 2/5, so we're going to slide over the 5 next to the m and minus 2, and we have our factored form. Our next example, make it a little bit easier to see, is 6y squared minus 5y minus 4. We're going to slide over the 6, so we have y squared minus 5y minus 24. What are my two factors of -24 that add up to a -5? Well, if I think about the fact that 24 is 6 and 4, which would either give me a 10 or a 2, or 8 and 3. And if I have a negative 8 and a positive 3, then I end up with what I'm looking for. So we take y minus 8 over 6 and y plus 3 over 6, both of which will reduce. So we have y minus 4/3 and y plus a half. But we don't want to leave the fractions, so we slide over the denominators, 3y minus 4 and 2y plus 1. And our last example, we multiply 12 times 5, so we have c squared plus 11c minus 60. What are the two factors of 60 that add up to 11? So we're looking for negative 60. So think about what are your two factors of negative 60 that multiply to give you negative 60 but add up to be positive 11. And that's going to be c plus 15 and c minus 4. We're going to divide by the 12. So we have c plus, we simplify that, 5/4 and c minus 1/3, and then we will have 4c plus 5 and 3c minus 1. And I've given you 3 examples that I now want you to pause the video and try on your own before I show you the factored form. Okay, here are my worked out solutions. Please check your work carefully. Pause the video so you can look at how I've worked out mine, and if you have any questions, I will answer them in class.